Before we get started with higher degree functions, we need to learn the properties of exponents. So how do we deal with expressions that have exponents that are higher than 2? Because so far, all we've dealt with is the highest degree is x times x, which is x squared, and we already know that. By the way, this little dot, in case you haven't seen it before, is just another way of writing the multiplication x. Typically used if x is the variable, because if you were to write that, you can easily confuse the x's and the multiplication sign. So anyway, x times x equals x squared. We know that. But why is that? Well, we're going to move into higher exponents to find out. So if I have x squared times x cubed, what is this equal to if we want to simplify it into one expression? Well, to figure that out, let's just break down each of these terms. So x squared is x times x, and x cubed is x times x times x. And so if we look at this, we see that we have 5 x's being multiplied. So x squared times x cubed is x to the 5th. And you'll notice that 2 plus 3 equals 5. So what we've just discovered is that when you're multiplying two terms with the same base, meaning what's being put to the exponent, base of x, and you're multiplying the terms together, then you can simply add the exponents to simplify the expression. If you want to prove this numerically, we can do that. Let's say we have 2 squared times 2 cubed. So the base of 2 is the same in both terms. Well, we just have to add the exponents to get 2 to the 5th. What is 2 to the 5th? It is 32. And you'll notice that 2 squared is 4, 2 cubed is 8, and 4 times 8 is also 32. So it works. So now what happens if we have a constant in front of one of the variables? Here we have 5x to the 4th times x to the 7th. Well, you can look at this is everything is being multiplied here. It doesn't matter that there is a multiplication dot here and not there. If it helps, you can rewrite it 5 times x to the 4th times x to the 7th. So we're not including this 5 twice or anything like that. It's just 3 separate terms being multiplied. So we can ignore the 5 and look at x to the 4th times x to the 7th. We add the exponents and we get x to the 11th times the 5, and we get 5x to the 11th. Here we have another one like that. We have 2 terms being multiplied here, 2 and x to the 5th, and another 2 terms being multiplied here, x squared and y cubed. So remember, it doesn't matter that it looks like it's these two pairs are separated. It's really just 4 terms all being multiplied. So you don't want to multiply anything twice. So all we do is we look at common terms. First we look at constants, just numbers floating out here. We have a 2. Then we look at all the x terms. So we have x to the 5th times x to the 2nd, which would be x to the 7th. And then we have a y cubed. Same thing if we have a parentheses here. Again, terms touching each other, the multiplication dot, the multiplication x, or parentheses, they're all the same ways of writing multiplying. So don't let that confuse you. We just multiply the common terms. So here we have a 3 times a 4 is 12. Those are our constants. Then we look at x's. So an x here is just x to the 1st. Any number to the any term or anything to the first power is itself, so you can put a 1 there if it helps. So then we have 1 plus 2 is 3. So x times x squared is x cubed, and then we have a y. Now here we have an exponent that is being applied to a -4 and an x that are being multiplied by each other. So how do we deal with this? Well, let's just ignore these terms on the outside of the exponent for now. This exponent of 3 is only applying to what's inside the parentheses, and this will just be multiplied by it afterwards. So we deal with distributing the exponent to the terms inside the parentheses first. So we're just going to keep that -1/2 y squared on the outside. So what we're going to do is cube these two terms individually. So first we have -4 cubed. Well, 4 cubed is 64. And now, with negatives, remember a negative times a negative is a positive. So a positive times a negative, again, will go back to negative. So we have -64 x cubed. We multiply the x to the third power, and we get x cubed. So now, again, we just separate all the terms. First, we look at the constants. -1/2 times -64 is +32. And then we just have an x cubed and a y squared, all being multiplied together. All right, let's do one more of this kind of problem, and then we'll go to something new. Okay, lots of stuff inside this parentheses being put to an exponent now. All this is being squared. So again, we're going to deal with that first and let this just sit on the outside. So we're going to square each term. -5 squared is +25. And then these are all just single variables, so they all get squared. X squared, y squared, z squared. Now remember, don't let the parentheses confuse you. It doesn't really mean anything. It just helps you separate things from each other. But again, each term is just being multiplied. So we look at the constants. 25 times 2 is 50. X to the 7th times x to the 2nd is x to the 9th. Y to the 1st times y to the 2nd is y to the 3rd. And then there's no other z terms besides the z squared. There we go. So that is multiplying terms of the same base when they have exponents. Now we're going to move into division. X to the 5th divided by x cubed. So let's start the same way we handled multiplication. Just simplify it all out. What is x to the 5th? Well, it's x times itself 5 times. So we have x times x times x times x times x over x times itself 3 times. X times x times x. Now, what is any number divided by itself? Well, it's 1. So here we have an x being divided by itself, an x being divided by itself, and x being divided by itself. So what we can do is what's usually called canceling out, where when you have something being divided by itself, typically in a fraction like this, the numerator divided by the denominator, it cancels out and becomes 1, and multiplying by 1 doesn't do anything, so we can basically just get rid of it. So let's see, we can put slashes through x times x, x times x, x times x. All that stuff is gone, so now we just have x times x on the top, which is x squared. So where is our rule here? 5 minus 3 equals 2. So when we're dividing, we subtract the exponents. When the same base, we can subtract the exponents in division to get the new exponent. And proving this numerically, 2 to the 5th over 2 to the 3rd is going to be 2 to the 5 minus 3, 2 squared, which is 4. And if we want to prove that, we just look at 2 to the 5th is 32, and 2 cubed is 8, and 32 over 8 will be 4. Okay, so there is another property of exponents. Now let's apply it to some problems. So just like with multiplication, we treat each different kind of term separately. We treat our constants separately from our x terms. So first we do 6 divided by 15, which we can simplify to 2 over 5, basically just simplifying that fraction. But now let's extend this fraction bar out, because now we're going to include the x's, simplifying. X squared over x to the 4th. So that's x to the 7th over x to the 4th. So that's x to the 7 minus 4, which is x cubed. And we're multiplying by this expression here of 2/5. So when we multiply, we put it in the numerator. So we're going to have 2x cubed over 5. We could write that a little more neatly, like that. Or if you'd like, you can also put the fraction in front, 2/5 x cubed. Either way is fine. Okay, here's something a little different. X to the 6th over x to the 9th. So we'll have this is x to the 6 minus 9, which is x to the negative 3. So this is new. Now we have a negative exponent. So what does that mean? Well, remember that when we have a positive exponent, we're left with something we want to multiply by, so it goes in the numerator. If we have a negative exponent, this means that we're dividing by x to the 3rd. So this is the same thing as 1 divided by x to the 3rd. 1 because there's nothing in the numerator. And as we've shown here, when we cancel stuff out, it just leads back to 1. So this is a property of negative exponents that you should know, which is that putting something to a negative exponent is the same as dividing it into 1. Or another way to look at that is flipping it from the numerator to the denominator, because if we want to rewrite x to the negative 3, we could say x to the negative 3 over 1. Maybe now you see this a little more clearly. All we did was we flipped the whole fraction. Instead of multiplying by x to the negative 3, we divide by x to the positive 3. It's the same thing. So now we can deal with negative exponents for these division problems. So first, deal with the numbers out here. 3 over 6 is the same as 1 over 2. So if we want to write this all in one fraction like we did over here, multiplying by 1 doesn't do anything. So unless we have nothing left in the numerator, we can just leave it blank. So 3 over 6 is multiplying by 3 over 6 is the same as dividing by 2. So we'll just put a 2 in the denominator. Now we have x to the 7th over x to the 8th, which is x to the negative 1, multiplying by x to the negative 1. Or dividing by x to the positive 1. So we can divide by x by putting that in the numerator, in the denominator. And now, since there's nothing left in the numerator, we don't want to just leave nothing there. We're just going to put a 1. Since there's nothing being multiplied by there, it's just a 1. All right, now we're going to start moving into longer problems. So here we have 16 over 6. That simplifies to 8 over 3. And again, you can write this in front and then put all the variables out here, or just extend the fraction bar out. For this one, I'd recommend extending the fraction bar out because it's likely we might have some positive exponents when we divide and some negative ones. If we change them all to positive exponents, then the ones that were originally positive go in the numerator, and the ones that are negative, we change them to positive and put them in the denominator. And that's exactly what we're going to do here. X squared over x cubed is x to the negative 1. Instead of putting x to the negative 1 in the numerator, we'll just put x to the positive 1 in the denominator. Same with the y's. We'll end up with y to the negative 1, so y to the divide by y to the positive 1. And then this z will stay up here. All right, let's do one last problem. So 3/5, this time we can't simplify it. So we'll just leave it like that. Now we have x divided by x cubed, which is x to the negative 2, or divided by x to the positive 2. Y squared over y is y, and z to the 4th over z squared is z to the 4 minus 2, or z squared. Okay, so we're going to stop here and continue with these exponent properties in the next video, where we're going to start looking at what happens when you put a power to a power. So something like this. Powers on top of powers. Interesting. Okay. We will start that in the next video.